2008. After that, he received a postdoctoral fellowship from the Nanoscience Technology under Nanoscience Technology Center at the University of Central Florida, USA. During this time, he was involved in several NSF-funded research projects, and he designed and developed quantum dot-based nanoprobes for nanobioimaging and sensing. Then he moved to the University of South Dakota, USA, for his second postdoctoral research, and he was mainly involved in the catalysis by nanomaterials. Dr. Banerjee has published several papers in peer-reviewed international journal and also presented research works in many international symposiums. He has also been invited to review papers from several international journals, such as Journal of Organic Chemistry, Tetragon Letters, Journal of Molecular Catalysis, a Letters in Organic Chemistry, Chemical Papers, etc. He was also a member of American Chemical Society. Dr. Banerjee has also been selected in Who's Who in America in 2011. He have already completed two major research projects. His lecture topic is Green Tools in Organic Synthesis today. With this brief introduction, I invite Dr. Subhash Banerjee to deliver his lecture. Over to you, sir.
Thank you. Thank you, Dr. Dafadar, for your nice and kind introduction. And thank you, Dr. Subhankar, for inviting me to deliver a lecture on this international symposium. And before that, I would like to thank Dr. Alakananda Hajra. He is my senior and we are from the same laboratory. So he paved the pathway. So already he has covered everything, most of the thing of green chemistry. So thank you, Dr. Hajra, for your inaugural lecture. And I am going to cover almost start with the same topic where he left. And in addition to the some aspect, I will cover one another aspect that is part the catalysis part or green catalyst part. So I'm going to share the slides. Please let me know whether it is visible to you or not.
Yes, sir, it is visible, but good full screen.
Yes, I am going to do that. Is it okay now?
No, sir. Make it full screen, sir.
Now I made it. Just please wait. It will come maybe. Not yet again.
No, sir. Please
Okay.
click.
No, I have done that, but let me see.
Yes, sir.
Yes, sir. It is now. Yes,
Oh.
it is okay, sir.
Okay, thank you. So I am going to discuss about the green tools in organic synthesis.
Please click on the hide link. Hide. Yes, sir.
Okay. So I am going to discuss about the green tools in organic synthesis. So already green, what is green chemistry? It is discussed, but in this presentation, I would like to pray Ma Saraswati for blessing us with this evening. And this is the photo of Baba Guru Ghasidas ji. In his name, our university is situated, and the university is located in Chhattisgarh. That is in a remote place. and it is upgraded to Central University in 2009. And before that, it was State University. And I'd like to also inform that previously we used to get a lot of students from West Bengal, but slowly as Bengal has so many universities that are open, so now number of students is less. And recently, our university is accredited A double plus by NAC. So I'm very happy to please to share that. And also UGC, it is categorized as category number 1 in the by UGC. So with this, I'm going to cover the green tools, namely green alternative energy sources, green solvent, and green catalyst. There are other tools also, but mainly in these 3 topics I'm going to cover. And I will give 2 examples of green nano catalysis, which is considered as one of the green tools in organic synthesis, followed by conclusion and acknowledgements. So green synthesis, what is the importance or need of this? Already explained in the past lecture. That is, pollution is the biggest problem that is caused by the soil pollution, water pollution, air pollution. And air pollution mainly arises from vehicle and factory emission. But if we consider, if we leave apart all these problems, but if we consider the problems of chemistry, as a chemist or as a industrialist, we are also equally responsible for pollution. And by using toxic and hazardous solvents, catalysts, and throwing them to the basin, which is eventually going to the nature, and it is polluting. But as a chemist, chemists are continuously working on this field and to minimize this. And the same slide I am showing, which I have seen from previous, that is the concept of green chemistry arises. And in summary, in last lecture, that it is about green chemistry is about reducing waste, material, hazard, risk, energy, and cost. So as already mentioned, that we may not be able to eliminate 100% of this, but if we try, or if we can reduce the production of waste, reduce the utilization of material and hazard risk, and also minimize the amount of energy that is required, along with the reduction of cost, that can be considered as a part of green chemistry. So what we can do, we can manipulate these are the part in our daily to daily life as well as in our research and teaching. So consider a simple organic or any chemical reaction, a basic reaction A plus B, that is giving C and D. So reactants are giving products. So what are the main parameter to conduct a reaction? We need some energy, we need may or may not catalyst, sometimes solvent or sometimes no. Starting material A and B, it is inevitable we need, and strategy. So basically here, middle of the part you can play. So that is the thing you can change, you can modify, you can do better. So here the parameter you can play in the laboratory, so to can get the organic synthesis or any chemical synthesis to convert from conventional synthesis to green synthetic part. So what you have in your hand? Mainly parameters. So you can change the parameter. So first of all, we have to discuss the green energy sources. So one of the important or source of energy is the mechanochemical energy. What is that? In maybe when I was in Siuri Bhatter College, I have done one practical, the reaction of acid with phosphorus pentachloride using a mortar and pestle to produce the acid chloride. I remember during that time we used to grind it for a long time and lot of fume used to come. So that is the problem of using this human-based mortar and pestle. So that mortar and pestle is now modernized. That modern technology, it is converted as a ball mill. So ball mill, what is? Just simply some bicycle ball, that balls are stainless steel ball that is put in a stainless steel container, and if we put this container here and if you rotate, that ball will rotate along with the reactants, it will generate energy and the reaction can be performed. So the previous technology is converted to some better or green technology. Here you can manipulate RPM, you can manipulate number of balls, number of the time required. So here and machine is doing, so no need to worry about the human energy. Here human resource is important. So that is the limitation of this part. So that can be modified as ball mill. So that is one green source, one of the green source of energy, that is mechanochemical energy, is ball mill. And that is another source of energy is microwave energy. Microwave already most of the household you are using for making the food hot or boiling potatoes or anything. What is the advantage of microwave heating over conventional heating? So it is selective heating. Selective means the microwave energy heat the substance or reactants directly by dipolar interaction and dipolarization. So if you have polar bond, that polar bond, that stretching and bending takes place and it gives a lot of energy. And here you can variation, you can perform that power, you can change the time, you can heat and RPM, etc. The advantage of microwave source of energy is faster and selective reaction. Why it is faster? Because in conventional, the vessel must be heated and the solvent, after that it will heat up, then it will heat up the reactants. But here the selective heating, the reactants can be heated directly by using microwave. So there is no loss of energy. So that is another green alternative energy source. This is the sonochemical energy by using a sonicator bath. Basically, we have to put here water and start the machine. Some noise is there, maybe somebody is on. So what is happening when the machine start, the sono means sound. It's when it started, it gives vibration and it produces bubbles in the water. And when bubbles are collapsed, it produces high temperature and high pressure and within the hot spot. So this is called hot spot. And when it is blast, it gives in that area high temperature and high pressure. And we need, excuse me, is there any problem, please?
No, sir. Please continue, sir.
Okay. So this acoustic cavitation produce lots of high temperature and high pressure, and that cavity are able to perform a chemical reaction. So you can imagine that in water you can produce high temperature and high pressure by using sonochemical energy. So this is another green alternative source of energy. And this is the best energy source, that is light energy. So one of the classical example of using light energy, the best example I can say, or everybody will agree, that photosynthesis. By using carbon dioxide, naturally available water, carbon dioxide and sunlight, and naturally available plants, that is the cooking the glucose and oxygen. So green energy source, that is sunlight, every day renewable, every day will get. Then carbon dioxide is available, it is non-toxic in nature. Water also available in the nature and non-toxic, and it produce instantly in the plant leaves glucose and oxygen, and the glucose is stored in the plant it is our one of the that produce carbohydrate. So that is our main food chain, and it gives byproduct oxygen, and this is our life. So this is the best example of green chemistry. So chemists are trying to mimic, or chemists are trying to produce, reproduce the nature synthesis of photochemical synthesis in the laboratory. If you can achieve 5 to 10%, then it's a huge success. And in the laboratory you can use LED light, so you can vary the wavelength and you can get the natural light wavelength also. So that we can do in the laboratory. And coming to the green solvent, the water is the best, as already discussed. For the any chemical reaction, if you can perform water, or you can change previously if it was done in organic solvent, and now if you can do in water, then it is also a part of green chemistry. Another part solvent is one of the good for organic synthesis and some analysis part, ionic liquids, that is ionic in nature and liquid in character. They have least vapor pressure, high boiling, very stable, and by you can prepare as in the laboratory as per your need. So it is called designer solvent. They are highly soluble in water but not soluble in organic solvent. So you can add some organic solvent to extract your material, so it can be act as also reusable. So it is also homogeneous but reusable. Supercritical carbon dioxide and alcohols may also be considered as another green solvent. Among green catalyst, catalysis part, we know that in BSc or MSc we study that homogeneous catalyst and heterogeneous catalyst. Homogeneous are reactive, heterogeneous are less reactive, because the reaction is performed in the surface of the material. But if we can increase the surface, we can if we can increase the surface area by decreasing the size. So, and if we go to slowly moving to bulk to nano, then they are dispersed, but even we can get that can be again recovered from the reaction mixture by filtration or by centrifugation. So we can get the advantage of reusability. So nano catalyst is basically play an intermediate between homogeneous and heterogeneous, and that can be considered as green catalyst because they are fine particle, highly reactive, reaction can be performed under mild condition, but they are also giving the advantage of heterogeneous catalyst by recycling. So I hope that you know the basic concept of nano. It is 1 billionth of a meter, but just by comparing the ratio of size of earth to size of football, and if we again compare the ratio of size of football to fullerene, then the parameter magnitude will be, amount will be same. So we know the size of football, so you can imagine the how tiny particle they are, and that can be only visible under microscope, electron microscope. So these are some nanomaterial, that's 0D, 1D, 2D, and 3D, depending on the different direction. And nano is now a so popular name that some commercial products are also appeared in the market as a nano form. That's Nano Razor, Tata Nano, then Nano Pure Water, and Nano iPod. So they are not nano in form, but their name are nano because the nano material is now so popular in the market. So what are the advantages of nanomaterial? So they have, as I mentioned, large surface areas and link between homogeneous and heterogeneous catalysts, and they are ability to perform under the mild condition. And here one pictorial representation, about 4 gram of single wall carbon nanotubes have the same surface area as a football field. So now you know the size of a football field. and you know the amount of 4 gram of carbon, amount this much of 4 gram means. So their surface area are the same. So you can imagine the how much and how big, larger surface area the nanomaterial they are having. Then about the nanomaterial, what are the advantage of metal oxide? I'm going to talk about metal oxide. They're easy to synthesize at room temperature and very stable. They agglomerate, but they have some hydroxide and oxide in the surface. So they have agglomeration tendencies little less compared to metal nanoparticle. And due to presence of oxide and hydroxide and metal positive charge, positive just Mn plus, they are having Lewis acidic and basic properties, and they are more reusable than metal nanoparticle. So among some nanoparticles, silica, zirconium, zinc, copper oxide that we are using in the laboratory, some metal ferrites and cobaltites also recently have been used. And these are the mechanism by which nanomaterial can interact with the substrate, and then they can ultimately they can release the product and regenerate the nanomaterial. So in Guru Ghasidas University, when I started here, we have used zinc oxide because nothing to hide that we had nothing in the laboratory, but I found that zinc acetate and zinc chloride are there in the UG laboratory. So using sodium hydroxide basic condensation, we prepared zinc oxide nanoparticle, and we started in 2012 with MSc project. And we have performed some multi-component reaction, and if somebody is doing organic reaction, they know these are very common and very highly easy to produce solid product, and it can be purified by recrystallization. So when you don't have, like in college, much facility, so you must try such kind of things where you get solid products, so you can purify it by recrystallization. So you don't need right away the NMR spectroscopy, you can wait for that. So we have done couple of multi-component reaction to prepare tetrahydrobenzopyranes, dihydropyrimidine, and benzothiazole oxazole derivative basic reaction, condensation, cyclization reaction. And we are lucky to produce some good publication in New Journal of Chemistry and Tetrahedral Letters. Then we tried some other metal oxide nanoparticle, that is zirconium oxide nanoparticles. And I am not showing the details of the preparation and their characterization, but just a glimpse of the, because the time also short. So again, you can see zirconium oxide oxide nanomaterial. These are the TM. This is TM image. Again, we have performed some multi-component reaction here and there and there, and we prepared pyrano 2,3C pyrazole, benzyl pyrazolyl coumarin. Here some chromine derivatives, and here highly substituted pyridine and pyrrolidine derivative. And again, we got lucky to have that green chemistry paper, RSC advances, couple of. So we are just exploring the different metal, their oxide form nanomaterial, and some multi-component reaction in the initial stage. And looking at the zirconium, I will discuss about only one reaction. They have high band gap, but mainly they have used in ceramics, wear resistance, optical coating, and fuel cell electrolytes and buffer. There are some sensing application also done. But in zirconium oxide, the nanomaterial they have used as a support for photocatalyst, but real application of ZrO2 was not explored, but only one we found the Novenagel condensation reaction. However, this nanomaterial was not implemented in multi-component reactions, which is one of the green synthetic tools, one for multi-component reaction. So we have prepared zirconium oxide by condensation method and calcinated at 500 and 800 to get tetragonal and meta monoclinic zirconia. And these are the powder XRD pattern of tetragonal and monoclinic. So you can see this is crystalline nature and this is amorphous, but the broadening of spectra, it indicates that highly fine particle and with particle size is smaller particle size formation. And these are the TM image. You can see that nearly spherical particle size around 16 to 18 nanometer nanometer size, and this is the FESM image. Again, it is showing that spherical size, and this is DLS and TM, you can distribution of the particle size around 16 to 18 nanometer. And using this zirconium, we have performed on reaction that synthesis of benzyl pyrazolyl coumarin. So coumarin derivatives are well-known biological activity, and also pyrazolone also have some antibacterial, anticoagulant, antioxidant activity. So we thought of what about integrating these two molecules in a same. So joining these two molecules, this is benzyl coumarin derivative, 3-benzyl coumarin derivative, and this is pyrazolone. So if we can prepare this molecule benzyl pyrazolone coumarin, so we can get the biological activity of both. So we perform in silico binding affinity prediction, and we found that benzyl pyrazolone coumarin is active to COX-2 inhibitor, and these are the some binding pattern we have done with the collaboration. And the cavity, this protein image cavity is fitted the benzyl pyrazolone coumarin via hydrogen bonding. And these are the some derivative we proposed, and these are the result of in silico binding affinity. And this is the celecoxib. This is commercially available drug, and the property of Moldock score, hydrogen bond score, and re-rank score of this drug, our drug, that proposed molecule is far better than this molecule. So then we have performed this reaction by one-pot multi-component synthesis, and for that we have used 4 components, just hydrazine, ethyl acetoacetate, aromatic aldehyde, and 4-hydroxy coumarin. Then in one pot, when we mix this with zirconium oxide nanoparticle 10 mole% in ethanol water mixture at room temperature, looking at the condition, these are the parameter: catalyst, solvent, and condition. So catalyst, reusable zirconium oxide, very 10 mole% only; water, ethanol, that is green solvent; and room temperature, mild reaction condition, and getting multi-component biological active products. So these are the parameter we have used here in the synthesis of benzyl pyrazolone coumarin, and it was solid, and the reaction time, you can see the 2 to 5 minutes. They are very fast reaction, and we have checked the catalytic reusability. It can be reused up to 10 cycle, as the zirconium oxides are highly stable in the reaction condition. We have also used some copper oxide. Then again, you can see our approach is to for multi-component reaction most cases, and highly substituted furan derivatives, and again some coumarin derivatives. And here one reaction we have performed, that aldehyde amine, and that is Teker synthesis. And we could again publish some chemistry select, RSC advance, and crystal growth design journal, ACS crystal growth design. Then the problem of this oxide was separation was tricky, because we have to use centrifuge hard time for each time for separation. So later on we have used some metal ferrites nanomaterial. So the advantage of metal ferrites are that they are magnetic in nature. So after reaction, you can separate the catalyst by using external magnet. You can see the vial; it's containing that metal ferrites, basically nickel ferrite. And from the reaction, if you put here external magnet, then all catalysts are stick to this, so you can decant. So you don't need to the use of centrifugation. And again, we have done some very simple reaction, Michael addition reaction, 1,4 addition reaction, and some again multi-component reaction, then transfer hydrogenation process, and then we have published again couple of RSC advance and chemistry select paper. But in summary, what are the green tool used here? We have used one pot multi-component approach. So the strategy, green strategy, water or ethanol was used as a solvent, and catalyst, the reusable nanomaterial was used as a mild catalyst, and inexpensive catalyst, water as solvent, and recycling. All the process it made our protocol is inexpensive or economic in nature, because we know we are in the economically challenged place, so we don't have much money initial stage. So still the separation was the main challenge. So we thought of preparing some support metal oxide nanomaterial by putting them on a support. So supporting material can be used organic monomer, organic polymer, inorganic polymer, or some carbon-based material. We are now working currently in this graphic carbon nitride support. But I will show you one example of using metal oxide, inorganic metal oxide as a supporting material. So here we prepared hierarchical mesoporous ruthenium oxide on cuprous oxide, a hybrid material, by using microwave radiation. Again, microwave is a green synthetic tool or green alternative source of energy, where we have used ruthenium chloride and copper nitrate as a source of starting material and hydrogen as reducing agent. Then we have prepared the ruthenium oxide on cuprous oxide. And these are the characterization: powder XRD and BET analysis, ICP analysis. We are not going to details. These are the TEM and APSM image of the material, which confirms the presence of ruthenium oxide and cuprous oxide. And here the XPS study confirms the presence of copper 1 cuprous oxide and ruthenium in for oxidation state. Then we have applied this material and oxidative azo coupling. So azo products are important dyes, and so the synthesis of azo compounds are highly desirable. But in the laboratory we have done by the using sodium nitrate by diazotization followed by coupling reaction. But one sustainable approach is the direct oxidation of amine to or aniline derivative to azo by using, that is performed by using gold on titanium oxide using oxygen balloon, and you can see it's published in science paper. And here we have used homocoupling, and we have performed homo and hetero coupling of aromatic amines to produce aromatic azo compound using ruthenium mesoporous ruthenium oxide and cuprous oxide. And these are the scope of substrate and for homocoupling, heterocoupling, and these are the kinetic study. So again, we have performed some experimental performance, and the paper was published in SES Sustainable Chemistry in Engineering. Again, you can see that we have used microwave synthesizer, source of energy, nanomaterial as reusable catalyst, easy separation of catalyst because now it is supported, so you can separate the catalyst by simple filtration. Another important we have done, that is we have not used any oxidizing agent or oxygen. Air was used as the oxidant, source of oxidant. So we don't have to carry the harmful oxidant or flammable oxygen. And I think I'm not going to cover other. So these are the some of the citations report and paper published current year, and currently PhD for 5 PhD awarded. I would like to acknowledge all the Guru Ghasidas Vishwavidyalaya for giving me opportunity to provide the funding and to work here. DST India, UGC, and CCOST for funding in different agencies. And these are the initially they have performed all the reaction. This is Dr. Arjit Saha, first PhD student. He got DS Kothari Fellowship from Hyderabad Central University. Then he worked in Shenzhen, and then now he got a postdoc in Spain. Dr. Somen Paira from Mednipur also, he got postdoctoral fellowship from IIT Kanpur and then IIT Madras, and currently in Jubilant Biosys in Noida. Archana Asatkar was a co-guideship, and she is assistant professor in Government Science College, Raipur. Dr. Patel also awarded PhD and postdoctoral fellow in Srinagar University, Noida. He also awarded PhD recently. He is also assistant professor, Government Science College, Bilaspur, and currently 3 students are working. And these are some information. You can contact me if you wish in future. Email ID ocsb 2006 gmail.com and phone number 7587401979. And it's not about we or everybody should unite to save our mother earth, preserving its green. Go green. And thank you so much for giving me chance to present before you, especially in front of Dr. Alakananda Hajara, my super senior. So if any mistake I have done, please pardon me. Thank you.
Thank you, sir. I think it is a very nice and informative lecture. Actually, sir presents all about things which he has done in content. This is green alternative energy, green solvent, green catalyst, nano catalyst, green tools in organizations, and more about I says about art figure, then reduce it to a football figure and then in nano figure. So just magnitude will change in different stages. So I think all the topics and all the portion are very nice. So thank you, sir, for your nice presentation.
Thank you so much.
Now we are starting our next session, that is questions session. So I am hand over to Dr. Sardar for this questions session.
Okay. Thank you, Dr. Sir. Thank you, sir, for your nice lecture. Thank you for the informative session. Now it's time for the question answer. If anyone want to ask a question, please ask from the audience. Please ask.
I don't think.
Then I want to ask a small question. Sir, you
Sure.
told that benzopyrazole kumari you prepared. It is theoretical portion or you synthesize in lab?
Theoretical prediction, just we have done some in silico binding affinity prediction, but the synthetic part we have done using zirconium oxide nanomaterial by 4-component condensation cyclization reaction.
Okay.
So that is done in the laboratory.
Okay. So how many
Okay.
precautions we should take when using some compound like zirconium?
Just could you please repeat?
When we are preparing compound like zirconium, what type of precaution we should take?
Zirconium oxide nanoparticle preparation, basically simple sol gel method, just basic condensation method. You take any zirconium oxychloride precursor and condense with sodium hydroxide solution using water and methanol solvent. Then it will get slurry. Then after calcination at different temperature, you get the different particle size. So it's just simple method. All the nanoparticle, basically metal oxide nanoparticle, they are very easy to synthesize. You can do anywhere, even in your home you can prepare. So whatever we are performing here, very simple chemistry, and without any even you can 100% predict that it is formed. Just after that you can perform the characterization. So very simple for organic chemistry. Nanomaterial preparation is very simple, especially oxide nanomaterial. So in even any college here, anywhere you can do. Very simple, and all multi-component reaction I have shown. There are so many catalysts are reported. So reaction eventually, honestly, it will go. But what you have to think in other direction, so to feed the paper. So you have to sell, basically sell the paper. So by replacing Lewis acid or some protic acid, you are just introducing some metal oxide in nano form, so that you can get much better activity in catalytic.
Okay. Okay. So your work is subject of combination between theory and experiment.
No, no. Where I am totally working on experimental theory, when we are getting some new or maybe not explored much molecule in collaboration, we are doing some theory.
Okay. Okay.
So it is not my part.
Okay.
So if anyone of you very interested, so later on we can do some.
Actually, I saw your in your slide there is some
What?
kinetic study. So how you did this kind of study?
That is some UV-based kinetic study that we used to take a allocate from the reaction mixture and study the UV in some time period. So we can monitor by UV absorption, that shifting of from aniline to azo, that we can monitor the amount of reactant consumed and amount of product from. So we got a linear structure. So that is a simple study, UV-based study.
Oh, okay. Okay.
Kinetic study means it's not physical chemistry. Some of the cases we are performing, but not all. But we are.
This is a basic study.
Excuse me, madam.
This is the basic study. If you want to study organic chemistry mechanism, generally we do in
Very
this way.
simple, very good, is very simple reaction.
Just we need a liquid from the reaction mixer and then UV machine.
UV study.
And
Yes.
after getting a result, you have to plot.
J.
Nothing else.
J.
Okay. Thank you, sir.
So someone raised his hand, Deep Muria.
Yes, Deep Moria, you raised your hand. Do you have some question? Deep Moria?
I think all
Yes,
of
sir.
Dr. Haja also want to say something.
I have one query, not question, sir. I am a field from mathematics, not chemistry. Sir, one query is that our seminar topic is green chemistry. Sir, why it is called green? And I think, does there exist any 3 R's, that is reduce, reuse, recycle? Is there any behind this term, this question green? Why it is called green, sir? It is my query, sir, not a question.
Yeah, that's a good question. Although you are from mathematics, but whenever we start from any green chemistry topic, so we start with the one line that green is not about the color of green color, or green is not about, green is about safety. So even when you are traveling or by a road, you will find red, yellow, and green color in your some road. You will find then. So green means it's safety, you can go. Yellow means there are precaution you have to take. Red means you have to stop. So green means basically safety. So safety by reducing the excessive use of non-toxic hazardous solvent, by reducing the minimizing
Yes, sir.
amount of catalyst, by using green or by not green, by using non-toxic starting material, production of valuable products, and not generation of byproducts. Or if byproduct is generated, that should be very much useful, like photosynthesis. Byproduct is oxygen, and you know the value of oxygen, you know the value of the basic sugar. So that is the perfect example of green chemistry. Green means here a reduction of hazardous, reduction of toxicity. It's safety, it's all about safety, reduction of human resource, so it's not about.
Yes. Thank you. Thank you, sir.
Thank you.
Okay. If
Okay, just one. I have one. Was
Ji.
yeah, nice lecture. So
Thank you.
what you are doing in your university, that is excellent. So I know that is a remote place. It's very difficult to do some research. So what you are doing, that is really excellent. That is also
Bas, all your blessing, blessing of Professor B.C. Rano that we can do anywhere, anything.
No, I understand, but still, whatever you are doing, you are trying, you are doing. That is the basically output. So I am just want to know. So could you please, you are preparing zinc oxide. So is there any possibility to prepare iron oxide by similar way?
We have prepared iron oxide because gamma iron oxide, or we are using ferrosulfuric oxide, Fe3O4. We are using metal like MFe2O4, like metal ferrites. So we are using that. I have shown some example, and you might miss that. I have performed your molecule, and that is
Hydroquinone.
imidazopyridine derivative.
Okay.
And that we got some selectivity of new reactivity of metal ferrites like nickel ferrite, and their organic solvent, that methanol, ethanol, alcohol is introduced in that two position. So two alcohol derivative we have prepared. That is the new molecule.
Oh, yeah, I understand. I got it. So anyway, you nicely described the preparation of nano. That is good for the. Probably there is some college teacher is there.
Yes, anywhere.
That is good.
Anywhere you can perform. That is the not called anywhere. If you don't have anything, you can prepare. You need just precursor salt, inorganic salt. That's it. Sodium hydroxide everywhere is present.
Okay, that's good.
Thank you.
Okay, Subhas. We will see later.
Yes.
Yeah. I am some not quite discussion. At first, I thanks the Professor Subhas Banerjee. One call, they agree with our proposal, and also Professor Alauddin Hajra.
Thank you.
Saying that when using a sonometer, they are form a bubble and blast increase the temperature. But one question, a bubble when blast, they will be the temperature reduces. Then overall system temperature will be controlled.
That's a good question, or maybe good point. But in sonochemistry, the mechanism or acoustic pressure and hotspot is generated, basically hotspot. So that hotspot, it creates by collapsing of bubble. But exactly inside what mechanism, I don't have deeper knowledge. So pardon me. But whatever the theory says of sonochemistry, that it generates bubble, and then bubble suddenly collapsed, and there generates a hotspot, and that is the principle of sonochemical method. So, but I am not working, and not only working, but also I don't know much about that exact principle behind this. So I may not be able to answer if somebody else maybe, but it generates. But really, I'll think about and I'll study that. Your question is nice that it will generate, but at this stage I don't know how it generates. But of course, the reaction proceeds by this hotspot formation and by acoustic cavitation.
Thank you, sir.
Thank you.
Papa,
বলো।
তোমার কি ওষুধটা হয়েছে?
If there is no question,
I think some Gurudeep have also raised the hand. Deep Moria also. Otherwise, we can stop here.
is there any question, audience?
No, sir.
Is there any question? No, sir.
Dimura raised his hand but not responding.
Yes.
I think maybe it is touched just
Yeah.
Yes.
somehow. Okay, thank you. I would like to thank principal of Bhatter College because our native place is there. So it's always good to see all these names.
Thank you, sir. Thank you. We are too much happy. And
I am also
when it's
happy, sir.
possible, offline seminar, you have to come to our college.
Sure. We'll come. Definitely, I will
Thank
come.
you so much, sir. Thank you.
Thank you, sir.
Okay. If there is no question, I again wish to thank to the speaker for this informative session and wonderful discussions. Thank you, sir.
Thank you for giving me chance. Thank you.
Okay, sir. Thank you. And thank you, Dr. Alauddin Dafadar, sir, for chairing the session. Now we have come to the third and last session of today's seminar. The speaker of this seminar in this last session is Dr. Soikot Mukherjee. He is the faculty of chemistry, Nicholas Copernicus University in Toruń, Gargarina, Toruń, Poland. He is an theoretician. Before his lecture, I wish to make a synergy between the theoretical chemistry and green chemistry. Green chemistry is a philosophy that applies to all the areas of the chemistry and aims to reduce the environmental impact of the chemistry, as we all heard. It focuses on the designing the products and the process that minimize or eliminates the use of the hazardous substances. Green chemistry and the computational chemistry have a synergy because green chemistry draws on the technique and approaches developed by the theoretical chemist. Computational chemistry is a field of chemistry that can predict the properties of the molecule that have not yet been synthesized. This makes the molecular design more rational. There is a close relation between the theoretical chemistry. Now it is well known as in silico chemistry and green chemistry. Before the lecture of Dr. Soikot Mukherjee, I wish to briefly introduce him to the audience. Dr. Soikot Mukherjee has completed his BSc and MSc both from the Viswabharati University. He ranked first class in the MSc. Then he completed his PhD in chemical chemistry from the Indian Association for the Cultivation of Science. Then he completed his first postdoctoral experience at the University of the Nevada, Reno, USA, in Professor Sergei Argonov group. His second postdoctoral experience in the Aix-Marseille University, Marseille, France, under the supervision of the Professor Mario Barbati group. Now he is a faculty of chemistry, Nicholas Copernicus University, Toruń, Poland. So far, he has published more than 32 peer-reviewed articles in various international journals. He had given more than 14 invited lectures in various international conferences and symposiums. With this brief introduction, I invite Dr. Soikot Mukherjee to deliver his lecture. His lecture topic is molecular photodynamics simulation in long time scale. So, over to you, sir. Start your session.
Thank you, Dr. Sardar, very much. First of all, I would like to thank the organizers for giving me this opportunity to talk in this international seminar.
In LDO, which of your microphone pitch.
So first of all, let me ask you, am I audible good? Am I audible well?
Yes.
Yes, sir.
Okay, and let me share my screen.